Okay, so the second part of the video is will prove the fundamental theorem of calculus part 2. So for f of x continuous over a closed interval a to b, and the big derivative of f of x is equal to small f of x, then the integrals from a to b of big f of x, no, the integrals of from the limit a to b of small f of x dx is equal to the big f of b minus f of a. Okay, so before we begin, we have to start with the fundamental theorem of calculus part 1, which state that if f is continuous on closed interval a to b, then a function is defined by the integral of f of t with the limits a to x when x is less than a and some number b, and if it's continuous and differential on the interval a to b, then derivative of a to x is equal to f of x. So this right here is the antiderivative of this function right here, and this right here is also the antiderivative of this function right here. So these two are basically almost the same as each other. Alright, so now if we want to take the integral of this function with what was said, then the integral of this would be this, because the integral we have a of x right here, and the integral of f of t would be the big f, the antiderivative of f of t would be the big f, and the big f evaluated at the upper limit x would give us big f of x plus r some constant when we take indefinite integrals. Alright, so the next step we're going to do is we're going to evaluate this a of x function at small a. So if we were to take the integral from a to a of the function f of t with respect to t, well, we would get 0. Why? Because to take the integral is to find the area under a curve. Well, it's from a to a, so it's not really a distance but a point, so the area under that point would be 0 because there are none. And we're going to continue to evaluate a of x at point b. When we do so, we know that evaluate by fundamental theorem of calculus part 1, when we have the function f of t, we will evaluate that function at the upper hand limit, which is b. So when we evaluate this function at b, we will get a b, because a of x is the antiderivative of f of t. So when you take the integral of that, we'll get the a of b. Okay, so we're gonna write this expression right here in a smart way, which will help us later on, because we know that this function is also equal to a of b minus 0 or plus 0, but in this case it's gonna help us early on if we have minus 0. So alright, okay, so with this expression right here, we can also write it as this expression right here. Okay, let's start with this little thing first. So we have a of b minus 0. Well, we already figured out that 0, a evaluated at small a is equal to 0. So we can replace 0 by a evaluated at small a. So we have this expression right here. And now we know that we know early on that the this function right here is also equal to this function right here. So we're going to replace this by the function evaluated at each point a and b. So at a, b, we have this function replaced by f of b plus some r constant minus the function a evaluated at a, which is also equal to big F of a plus some r constant. So before we even do anything, we can see that plus r minus r is going to go away, so constant is going to go away, and at the end we get big F of b minus big F of a, and that's what we want. So we're done with the proof. So now let's just do an example that allow us to implement the fundamental theorem of calculus. So we're gonna do this example right here. So we're gonna take the integral of this function 5 minus 2t plus 3t squared, evaluated at the lower limit at 1 and the upper limit at 4. So before we can use the fundamental theorem of calculus part 2, we will implement part 1 by taking indefinite integral without these limits right here. So if we were to take the integral of this function right here, we would get alright, we would get my apology, we would get this expression right here. So we're going to take the integral of 5 with respect to t minus integral of 2t with respect to t plus integral of 3t squared with respect to t. And as we learned that the integral of a constant is a constant of an integral, so we take all the constant out, 5, 2, 3, and then we have this, and now we will find the antiderivative of these inside integral right here. So for the first integral, we would get 5t, because integral of the dt would be t, because right here it's just 1, so if you take integral of that, it's just 5t. And after you take the indefinite integral, you always have to plus a constant, so we have a constant right here, and the antiderivative of t would be t squared over 2, and t is still here, plus a constant, plus 3, and antiderivative of t squared would be t cubed over 3 plus a constant. So after that, we're gonna do some cancellation. So 5t would come down here, and a constant, well, the reason why a constant, there's just one constant right here, because a constant plus a constant plus a constant is 3 constant, but they're still constant, so we're gonna leave that at the end right here. And this expression right here, we would cancel out 2, so we get negative 2 squared, and plus we cancel out 3, so we get 3 cubed right here. And now we have the function which we can use to by the fundamental theorem of calculus part 2. This is the indefinite integral function. So now we're going to evaluate this function right here at 1 and 4 with our equation, with our formula from fundamental theorem of calculus part 2, said that to find the integral, you would evaluate the limits. You will evaluate the antiderivative, the big F, at the higher limit minus the lower limits. So you would evaluate this function right here at 4 minus the same function at 1. Okay, so if you evaluate, you would get 5. You replace t with 4, and right here same thing, and you do the same thing for f of 1. You would replace 1 with all the t function. So 5, 4, 24 squared, 16, plus 4 third, that's 64, plus constant, minus 5 multiplied by 1 is just 5, 1 square is 1, 1 cubed is just 1, and constant down here. So okay, and after we do the simplification and calculation, it comes out the answer is 63, and we can see that the c will cancel out because there's a minus sign here. So the answer that we have with correct calculation is 63, and we're done.